Oh, by the way, just to add, so kasi parang sa Pilipinas, ang hirap nating kumawala dun sa natutunan natin. It's actually very hard, I think, for Filipinos to unlearn or to deviate dun sa mga nakasanayan nilang practices. For instance, etong online classes, So there are really some universities na sinimulan nila yung transition to either a hybrid or a purely online class. And of course, it is not applicable for all courses or all degree programs. Pero at least merong portions na lahat ng kaya nilang i-migrate to online, lalo na yung digitalization halimbawa ng processes or records sa industry at saka sa academe, nasimulan nila. Pero sa Pilipinas, parang kung hindi pa nagkaroon ng pandemic, hindi pa tayo mapipilitang mag-shift. Either due to, sige, granted na baka wala tayong capability infrastructure-wise, pero sana nakita na yun ng government nun. Nandun yung government, dapat meron silang foresight na digital is the new future, right? Or should be the new normal. So dapat na-drive nila yung mga key industry players or key societal players para dito sa information paradigm o sa online paradigm. Pero siguro yun yung naging silver lining ng pandemic na eto, natututuloy tayong mag-Zoom o mag-MS Teams to conduct businesses. And hopefully we learned na hindi naman pala lahat kailangan face-to-face. So marami tayong mga bagay na pwedeng i-migrate online for everyone's convenience and siguro comfort na rin. Pero anyway, those are just my random thoughts this afternoon. Dahil sobrang init, nag-check ako ng phone kanina, parang 37 degrees, umabot kaninang tanghali. And yeah, maabot nga pala ng ganun kainit dito sa atin. But hopefully, luckily medyo makulimlim na ngayon dito sa amin. So medyo lumamig na konti. 35 na lang daw kami or 34 degrees. Pero mainit pa rin, But anyway, so kahit mainit yung panahon, tayo naman ay, eto tayo, gustong matuto, At habang nag-aaral ay may hawak pa rin na kape. May kape ngayon akong hawak. Kahit nagre-reklamo ako na super init, hindi ko na kung bakit. Pero parang hindi kompleto yung pag-aaral ng math kung wala tayong kape, at least for me. Sabi nga, I forgot who this mathematician who said na, a mathematician is a machine that turns coffee into theorems. All right? So baka naman makagawa ko ng theorems. Kaya naman dinadamihan ko na yung pagkakape sa araw-araw. Pero yan, sige na, tama na yung kwento. So let's go back. So but first, housekeeping matters muna. So we'll finish the third unit today. So tomorrow, May 6th, I can give you problem set number 2. At the latest 9 p.m., i-ano ko siya sa Canvas. So para mabasa niyo siya over the weekend or habang kayo, basahin niyo na siya over the weekend kahit wag niyo sagutan. Just familiarize yourself with the questions. Para maplano niyo yung gagawin niyo. Kasi habang nakapila kayo sa inyong voting precinct, because we need to really exercise our solemn privilege and our civic responsibility of voting. So habang nakapila kayo para hindi sayang sa oras, basahin niyo yung problems tapos pwede niyo pag-isipan yung gagawin niyo sa problem set. I'm thinking either 3 to 4 problems ang required na isa-submit. Number 1 is your, of course, essay part question. 5 questions siguro na essay type. Tapos isa or dalawang proving. Tapos, gusto niyo pa ba ng objective na tipong true or false? Or multiple choice na problem? Pwede kasing ganon, 4. Or pwedeng isa na lang yung proving para 3 questions lang yung sasagutan nyo. Pwede rin naman 3 questions tapos yung dalawang proving na lang. Ano mas gusto niyo? May objective o puro proving na lang? For example building. Or hindi nyo masabi? Kasi sir, kahit ano naman, pinapahirapan mo naman yung questions, So parang no choice then. So let me think about that. Either 3 to 4 problems. Anyway, you'll have 4 working days to do it. You'll have Tuesday, Wednesday, Thursday, and Friday. So the deadline is Friday, right before midnight. So 11:59 p.m. via Canvas. All right, and then I'm counting the days. The last day of classes is on June 9th. So, meron pa tayo sigurong mga isang buwan para matapos yung course. I was reviewing my 155 playlist last semester. Mukhang kailangan pa natin after this, 6 na lectures pa yung kailangan ko para matapos yung dalawang natitirang units. So I think manageable pa naman. We have one or two lecture sessions to spare. Kahit nag-holiday nung Tuesday ano, tapos ano pa ba? Tapos magpa-problem set tayo probably first week of June, all right? And then we'll have a final exam. The final exam will be during the schedule of the finals week by the registrar. Pero don't worry, our final exam will just be a reflection paper. So I want you to list down your reflections or your takeaways from the course. So that's 10% of your grade. Oh, isasama ko rin pala yung course evaluation natin. So may papasagutan ako sa inyong survey para further improve itong course and my way of teaching. So yun yung schedule natin for the rest of the semester. Tapos makakapagpahinga na kayo, mid-year na, or yung iba sa inyo ay magpa-practicum malamang. So yun yung natitira nating mga dapat gawin. Si Charles daw bibili na ng isang sakong kape, no? Yeah. Actually, ginagawa ko yan every month. Pero ano naman, 1 kilo lang naman ako every month. 1 kilo ng coffee beans. Tapos sa akin lang yun. Hindi ko pinapagamit sa bahay. So, ano siya doon. But anyway, so let's just recall what we did last time. So last time we talked about uniform continuity and some takeaways from it is parang ito yung extension ng konsepto ng Cauchy sequences para naman sa mga functions. Kasi sa Cauchy sequence, habang lumalaki yung subscript dun sa listahan, palapit ng palapit yung mga values ng mga terms sa sequence. Habang nandun ka sa kanan ng listahan, habang yung subscript n ay lumalaki ng lumalaki. Now, dito sa uniform continuity, ang nangyayari rito ay habang palapit ng palapit yung mga x's sa bawat isa. So habang yung mga domain elements ay nagiging dikit-dikit, then ganun din yung nangyayari sa mga function values. Because remember, epsilon and delta are just our notations for very small numbers, right? And then the absolute value of a difference just represent ano yung nasa pagitan or gaano kalayo yung minuend mula dun sa subtrahend. So this guy is telling us that making x and y very, very close to each other will imply that the function values or their function values will also be very, very close to each other. So yun yung konsepto ng uniform continuity. But if you will look at it from a more technical point of view and you will read the definition the way it is, the most striking difference with the notion of continuity are two things. Number one, yung choice mo ng delta ay hindi nakadepende dun sa element ng domain. All right? So whenever a function is uniformly continuous, you can find a uniform delta na pwede mong gamitin sa kahit na anong epsilon greater than 0 at kahit ano pang x na nandun sa set. Because remember, when we did the preliminary analysis for proving continuity of functions, ang nangyayari doon, naghahanap tayo ng delta. And sometimes that delta might be dependent on the choice of x sub 0. Or hindi choice of x sub 0, kundi kung saan mo ine-evaluate yung limit. Katulad nung x squared. Dun sa isa nating preliminary analysis, nakita natin na kung gusto kong i-prove na continuous si x squared at the number x sub 0, then it is necessary that I choose the delta or it is sufficient that I choose the delta to be the smaller between 1 and epsilon over twice the absolute value of the number x sub 0 plus 1. So ibig sabihin, yung pagpili mo ng delta nakadepende kung saan mo tinetest yung continuity. Pero pagka yung function mo uniformly continuous sa isang set, laging hindi kailangan nakadepende yung delta mo dun sa number dun sa set na yun. Kaya nga uniform yung delta dun sa lahat ng members ng set para sa continuity. Right? And the second difference of uniform continuity from simply continuity, ang uniform continuity ay laging nakakabit sa konsepto ng isang set. Yung description nito, uniformly continuous, only applies to set themselves. Wala tayong sinasabing uniformly continuous at a number. All right? Laging uniformly continuity on a given set with more than one member. Okay? So yun yung idea. And then from there, you can realize that, okay, uniform continuity is a higher level of continuity. So mas marami kasing requirement yung uniform continuity. So in that sense, we can say that if your function is continuous, it is not necessarily guaranteed that it is uniformly continuous. Yung x squared nga, continuous yan kahit saan, pero hindi siya uniformly continuous. Pero lahat ng uniformly continuous functions ay automatically continuous. Okay? And then we proceeded with being true to the template that we have established for this unit na lagi nating itinatali yung mga konsepto natin para sa mga functions sa isang konsepto involving sequences. And that is still true for uniform continuity. We said that the function f is uniformly continuous on a set if and only if for any two sequences in that set, such that yung sequence ng mga differences ng mga terms dun sa sequence. So pag binuo mo yung sequence xn minus yn, tapos nag-converge yun kay 0, that will imply that the limit of the sequence form by the difference of the respective function values ay equal rin kay 0. And the nice thing about Theorem 3.8 is that it is a characterization theorem. It's an if and only if statement. So kapag ka uniformly continuous, automatic, magiging true ito sa lahat ng sequences xn and yn dun sa set E. Or the other way around is also true if for some reasons or for some nice circumstances, napakita mo na ito ay totoo sa lahat ng posibleng pair of sequences xn and yn, then that is sufficient to conclude uniform continuity. All right? Pero parang yung second case na binanggit ko ay hindi ganon ka-realistic. Kasi ang hirap na magpakita ng na mag-consider ng dalawang arbitrary sequence. Imagine taking just sequence without any characteristic. Kailangan mo lang dapat yung sequence mo ay nandun sa loob ng set tapos ang limit ng xn minus yn ay equal kay 0. Mahirap gamitin yung implying uniform continuity from a practical point of view, all right? Kasi nga kailangan totoo ito sa lahat. Pero the true gem that is hidden in Theorem 3.8 is basically, I think, one of the contrapositives ng components ng Theorem 3.8, and that will provide us with a sequential criterion for non-uniform continuity, and that's what Corollary 3.5 is telling us, and I think ito yung simula nung hindi natin na-cover last time. Okay. Now, what does Corollary 3.5 says? Sabi niya, kapag meron kang isang function na na-define kay E, hindi siya uniformly continuous kapag nakakita tayo ng dalawang sequences na nandun sa loob ni E, alright? Such that yung sequence ng xn minus yn ay nagko-converge kay 0, pero yung sequence ng difference ng kanilang function values ay hindi nagko-converge kay 0. And I hope you see why this is true or why this directly follows from Theorem 3.8. Ano? Kasi nga sabi sa 3.8, kapag ka lahat ng pair ng sequences such that xn minus yn converges to 0 implies that f of xn minus f of yn converges to 0, then f is uniformly continuous. Pero sinasabi ng pero implication nun ay kapag ka nakakita tayo ng dalawang sequences, na totoo ito, pero ito ang nag-hold. Yung sequence ng f of xn minus f of yn ay hindi nag-converge, then automatically f is not uniformly continuous. Okay? Ito yung mas practical na gamitin test for non-uniform continuity. And to illustrate that, let's consider example 3.9. Babalikan natin yung function as sine of 1 over x. I think we met this earlier in the unit when we parang pinurub natin on na etong function h na to ay hindi continuous when x is equal to 0. Alright? So ngayon, babalikan natin siya, pero ang goal natin ngayon, mapakita na siya ay continuous pero hindi siya uniformly continuous sa closed interval 0, 1. Okay? Now, ganito yung pwede nyo gawin kasi dalawang parts yung proof. Una, pakita mo muna na si H ay continuous sa open interval 0, 1. Tapos, yung pangalawa, ipakita mo na kahit siya ay continuous, hindi naman siya uniformly continuous. Okay. Now, to prove continuity, pwedeng ganito yung gawin nyo. Ganito rin sa homework, sa problem set, and so on. Kasi meron tayong one-sentence remark, kung natatandaan nyo, somewhere above, na sinabi na natin na polynomials and rational functions are continuous everywhere. Tapos idagdag nyo na dun sa listahan, pinapayagan ko na kayo na gamitan without proof na ang trigonometric functions, inverse trigonometric functions, exponential, logarithmic, what else? Hyperbolic, inverse hyperbolic functions, lahat sila ay continuous sa kanilang mga domains. Meron pa ba akong nakalimutan? Ano pa yung kilala nating simpleng functions sa 36, 37, 38 na alam na natin ay continuous? Yun lang, no? Yun lang yung mga usual nating pinaglalaroan nun. So, hindi nyo kailangan siyang i-prove pagka mga ganun kasimpleng functions, ano, yung mga basic functions na katulad nun. But for instance, halimbawa, eto, continuous yan. Paano mo i-argue na continuous yan? Well, you can say that, 1 over x is a rational function whose domain is a superset of the closed interval 0, 1. So that means 1 over x is defined on the open interval 0, 1. Tapos sabi po nung remark natin dati, yung rational function of 1 over x will be continuous on the open interval 0, 1. Moreover, the function sine x is continuous on the on the open interval 0, 1. And then the function h, being the composition of the sine function and the rational function 1 over x, is also continuous. All right? Ito yung pinapanood ko sa inyo na recording dati. Meron tayong theorem na nagsasabi ng composition ng dalawang functions with appropriate domains ay continuous pa rin. Sasabihin nyo lang, oh, this is sine x circle 1 over x. Parehong continuous yung pinapag-composition ko, so dapat itong composition na to ay continuous pa rin. And we're done with the proof of continuity. Nasagot nyo na itong exercise na yan. Now, the crucial part here is to prove that it is not uniformly continuous. Now, gagamitin natin yung sequential criterion. Kailangan nating umisip ng dalawang sequences, xn and yn, na yung xn minus yn ay magko-converge kay 0. But we are keeping our fingers crossed na yung sequence ng mga function values ay wag sanang mag-converge kay 0 din. Okay? Now, ito yung medyo kailangan ng creative thinking sa math, sa proofs, sa 155. And this is quite true in general for analysis or for analysis courses na madalas kailangan nating mag-construct ng mga bagay-bagay. Ano? So dito, luckily, binigyan na tayo ng clue ni lecture notes. Ang kunin ko raw xn ay ito, kunin ko raw na yn ay ito. Ang tanging requirement lamang, dapat sila ay nandun sa domain. Alright? Nasa loob ng domain or set of consideration. The set of interest that we have here is the open interval 0, 1. Both of these are greater than 0. Tapos ang denominator nila ay laging mas malaki kaysa sa numerator. So we're sure that these two guys are less than 1. Okay, so indeed, yung sequence xn at yn ay subset ng open interval 0, 1. Tapos ano pa yung kailangan? Dapat yung difference nila magko-converge kay 0. So pag kinuha ko yung xn minus yn, magiging 3 pi over 2 plus 2n pi minus pi over 2 minus 2n pi all over pi over 2 plus 2n pi times 3 pi over 2 plus 2n pi. Tagal ko na hindi nagka-fraction, so tama sana yung ginawa ko. So ito will cancel each other out. 3 pi over 2 minus pi over 2, that's pi. So the numerator is a constant. Laging numerator ay pi. Pero what happens to the denominator? The denominator involves the variable n. So habang si n ay lumalaki, yung denominator ay mas lumalaki. So the denominator will increase indefinitely. Remember, we have a constant in the numerator. Tapos ito ay nag-approach sa infinity, constant over something that is very humongous, that will go to 0. So indeed, xn minus yn will converge to 0. Kasi nga yan, medyo excited tayo, na anxious din at the same time. Titingnan natin, ano kaya yung mangyayari sa sequence ng difference ng mga function values nila? Well, compute natin yung f of xn ay equal sa sine ng 1 over pi over 2 plus 2n pi. Okay? Tapos, simplify niyo yung fraction. So, ito lang yung mangyayari. Tapos, n pi plus 2n pi. So, nasa north quadrant tayo. Tapos, plus a multiple of 2 pi. 2n pi to dapat. Okay? So, ibig sabihin, paikot lang tayo dyan ng paikot. So ang angle o yung real number na kinukunan natin ng sine ay laging nandun lamang sa position angle pi over 2. So ibig sabihin ang sine natin ay ito ay laging equal kay 1. So all of the f of xn's will be equal to 1. And in a similar manner, we can say that f of yn is always negative 1. Kasi dito naman papatak yung argument ng sine function. And then if we subtract them, f of xn minus f of yn, ang makukuha nating sequence ay puro 1 minus negative 1 or 2 lamang yung laman. So we have a constant sequence for f of xn minus f of yn, and the constant term is 2, and definitely that will not converge to 0. And hence, yeah, sinwerte tayo. Tama yung pagpili natin ng xn at saka yn. So we are done. We have shown that the function h is not uniformly continuous. But again, the crux here is yung pagpili ng xn at saka yn. Ito yung medyo pag-iisipan natin ng matagal. Pero luckily, binigay na siya ni handout. So wala na akong masyadong problema. Okay? So we will see another instance of, or another illustration of corollary 3.5 later. But, so kung walang tanong, didiretso na ako sa theorem 3.9. Mag-alas stress na pala kagad. 30 minuto na kagad yung nakalipas. Anyway. Okay. Theorem 3.9 gives us a sufficient condition for uniform continuity. Okay. So, ito yung isang special scenario na pag nangyari ito, automatic yung uniform continuity, which is helpful for us because traditionally, ang hirap magpakita ng uniformly continuous. And yung pagiging uniformly continuous, napakalaking bagay nan. Siguro after we prove 3.9, I'll tell you one instance where uniform continuity is very important. Yun yung nakalimutan kong sabihin sa kabilang section kanina. Pero yeah, para makabawi naman ako sa inyo. So sa inyo ko na lang sasabihin. Tapos share nyo na lang sa kanila. Pero ang sinasabi ni Theorem 3.9 ay kapag si f ay continuous sa isang compact set, then automatic si f ay uniformly continuous na dun sa compact set na yon. Ito yung makikita nyo na isa pang magandang value sa isang compact set. Alright? A compact set doesn't just preserve, or being compact is not just preserved under a continuous map. Alright? Meron siyang kaakibat na binibigay na power dun sa isang continuous function. Kung compact set ka, kahit anong continuous function nang i-define ko sa'yo ay necessarily nagiging uniformly continuous. Okay? Ito yung isa sa kagandahan ng mga compact sets. But a quick recall, ano nga ba yung ibig sabihin ng pagiging compact? Now, sabi natin medyo mahirap gamitin yung definition ng compactness. Kasi sinasabi ng pagiging compact, ang isang set ay compact kung at kung lamang nangyayari ito. Ano yung dapat mangyari? Dapat sa kahit anong sequence na nasa loob ng compact set na yon, dapat magkaroon ng isang convergent subsequence. At yung subsequence na yon, dapat ang limit niya ay nandun sa loob ng compact set. Pero usually, mahirap siyang i-imagine or i-illustrate, pero napakaganda nung pwede na siya yung magandang gamitin sa proofs. Pero mas magandang visualization o characterization ng mga compact sets ay ito yung sets na closed and bounded. Remember, we have a result that tells us that the set is compact if and only if it is closed and bounded at the same time. All right? So yun yung dalawang posibleng interpretation natin sa isang compact set. So the proof here will reveal bakit nangyayari na yung continuous functions ay na-force to be compact inside a compact, ay na-force to be uniformly continuous sa loob ng isang compact set K. Alright? So let's go over the proof. Pwede ko siyang isulat ulit, pero dun sa kabilang section kasi, nag-annotate ako sa ibabaw ng proof kasi may mga little typos na hindi ko na-correct last semester kasi sinulat ko ulit from scratch yung proof. Kaya nakalimutan ko siyang i-correct. To prevent that from happening, para yung mga next students ay medyo mas perfect na mas perfect. Sinabi ko tuloy na perfect na yung lecture notes. Mas okay yung lecture notes for next semester. I-annotate ko na lang over dito. So, okay. Ang approach daw ng proof ay by contradiction. So, we will assume that we have a continuous function f on a compact set K, pero hindi siya uniformly continuous. Okay? Kung siya hindi uniformly continuous, ibig sabihin, makakakita tayo ng dalawang sequences, alright, sa loob ni K, such that yung limit ng xn minus yn ay equal kay 0, pero yung limit ng f of xn minus f of yn is not equal to 0. So it is basically a contrapositive of one of the components of the characterization theorem, theorem 3. What was that? 3.8? Yeah, kasi sabi ng theorem 3.8, kung ito ay totoo, dapat siya uniformly continuous. So yung contrapositive nun, not uniformly continuous, implies false etong implication na to. Kailan nagiging false ang isang implication? Kapag true, implying false. Alright? Kaya ang assumption natin dito, nakakita tayo ng dalawang sequence na totoo ito, pero ito ay hindi totoo. So yun yung sinasabi dito. Okay? Doon yan nakuha. Okay? So, all good? Tapos ngayon, alam ko si K ay compact. Dahil si K ay compact, makakakita ako ng subsequences ni xn at ni yn. Tawagin natin siyang xnk at saka ynk. So that's the first correction. Palagyan lang naman ng braces, okay? Na etong dalawang subsequences na to ay nagko-converge to their respective limits x and y inside the compact set K. Pagiging compact, ginamit ko lang siya. Okay. Tapos for some reasons that will be clear later, kiniklaim ko na si x at saka si y ay equal sa isa't isa. Okay? It's not hard to imagine because remember xn minus yn converges to 0. So dahil nagko-converge yung difference, yung subsequence na mga differences, xnk minus ynk should also converge to 0. Tapos it makes sense to think na, okay, kung yung xnk minus ynk ay nagko-converge kay 0, ibig sabihin in the long run, si xnk ay nagiging kamukhang-kamukha na ni ynk, na halos nagkakapalit na sila o nagkakapareho na sila ng mukha. Alright? So that means it's logical to conclude na, mukhang si x ay dapat equal kay y. Sino si x at sino si y? Sila yung limits ni xnk at ni ynk respectively. Okay? Pero syempre, hindi pwedeng ilagay sa proof na lagi silang magkadikit, so nagkakapalit na po sila ng mukha. Bawal yon. Kailangan nating i-formalize yung argument. Paano yung argument? Itong mahabang equality na to. Let's see how was it written. Okay? So si y, okay, siya yung limit ng y and k by our assumption, by our notation. Si y yung itatawag natin sa limit ng y and k. Tapos, ito yung usual trick na nakita na natin sa analysis over and over again. You can add and subtract something or a quantity to another quantity. All right? Dahil alam ko na si x and k minus y and k ay nagko-converge kay 0, then yung x and k minus y and k, alam ko bilang subsequence siya nitong parent sequence na to ay magko-converge din kay 0. Tapos, pag nag-multiply ako ng -1, okay, totoo pa rin, nagko-converge pa rin yung kay 0 by the algebraic limit theorems for sequences na pag nag-multiply ka ng isang constant scalar dun sa isang convergent sequence, yung sagot ay convergent pa rin at magko-converge siya dun sa scalar times the limit of the original sequence. So I know that y and k minus x and k will still converge to 0. Tapos yun yung dahilan kung bakit nag-add and subtract ako dito ng x and k. Because I don't know how y and k behaves other than it converges to y. Ang alam ko na lang na other information is that y and k minus x and k converges to 0. And I'm hoping that I can use that in one way or the other. Okay? So yun ang ginawa ko. Pinersa ko na meron tong minus y and k. So para ma-preserve yung equality with the previous quantities, nag-add ako pabalik ng x and k. So essentially, this is just y and k. So walang nabago. Justified pa rin yung equality. But the nice thing about this is that y and k minus x and k we know is convergent to 0. This guy converges to x. So dahil nagko-converge yung dalawang addends, yung sequence of the sum ay magko-converge din. At ito ay magko-converge dun sa sum ng mga limits. Right? So the limit of this guy, the entire limit, is equal to 0 plus x. And x is actually the limit of x and k. And in summary, what we have shown is that y is equal to x, as claimed. Now, okay sir, nag-effort ako dyan. Para saan? Para saan ko naman yan gagamitin? Well, ano pa ba yung hindi natin nagagamit na assumption dun sa proof? Hindi pa natin nagagamit yung continuity ni f. Alright? So, paano ko siya gagamitin? Eto na. So, kung remember, f is assumed to be continuous. So, dahil continuous yan, by the sequential criterion for continuity, alright, si x and k ay nagko-converge kay x. So yung sequence ng function values, f of x and k, ay magko-converge kay f of x. Again, that is because continuous si f. Ganun din, si f of y and k ay magko-converge din kay f of y kasi nga continuous si f. But what is f of y? F of y is equal to f of x since y is equal to x. Okay? So pareha sila nagko-converge kay x. So pag kinuha kay f of x, so pag binuo ko yung sequence ng differences, f of x sub nk minus f of y sub nk, magko-converge ito dun sa difference ng kanilang respective limits. This guy converges to f of x, the other guy converges to f of x, so their difference will converge to the difference of the limits, which is equal to 0. Okay? So ngayon, nakakita na tayo ng isang subsequence ng mga function values. So subsequence siya nito. F of xn minus f of yn, yung parent sequence ng subsequence na ito. Kaya lang, itong subsequence na to nagko-converge kay 0. Pero ito hindi nagko-converge kay 0. So something is wrong with that. Right? Because we know that this is convergent by the continuity of f, right? So dahil ito ay continuous, yun nga lang, ito ay convergent, yun nga lang hindi siya magko-converge kay 0. So kung ito ay magko-converge to a number other than 0, so dapat lahat ng subsequences niya magko-converge then to the same number. But here we are, able to construct a sequence that converges to 0, defying yung pagiging convergent ng f of xn minus f of yn sa isang number other than 0. And hence that is the desired contradiction. Dahil may contradiction, so ibig sabihin, we need to accept that our supposition is false. What is our supposition? Our supposition is that f is not uniformly continuous. So mapipersa tayo na tanggapin, okay, sige na nga, kapag ka meron kang continuous function sa isang compact set, automatic yun ay uniformly continuous. Alright? Now, para saan yung uniform continuity? Isa sa mga pinaka-immediate na nakikita kong applications or nagamit kong applications ng uniform continuity. Hold on. Uniform continuity ba yun o absolute continuity? Yeah, I think it's uniform continuity. Ay pagdating natin sa integrals. Okay? Hindi, sequences pala yun. Uniform convergence, absolutely convergence. Isip ko palang application ay absolute convergence. Hindi pala siya uniform continuity. Yeah. Para ma-phrase ko siya into uniform continuity, kailangan kong dumaan sa sa series, sa infinite series. Pero ultimately, yung idea nito ay ginagamit kapag kumukuha ka ng integral ng isang infinite series. Kasi alam natin na kapag nag-i-integrate ka ng sum, equal lang yan sa sum ng integrals. Tama? So yun yung additive property ng integral. Kaya lang kapag infinite na yung number of terms, meron kang infinite series, hindi mo basta-basta napapagpalit yung order ng integration at saka ng summation. So pag meron kang integral ng summation, going from 1 to infinity, hindi ito laging equal sa summation ng integral. Totoo ito kapag hanggang isang capital N lang yan. Pag finite, yung pinag-add mo. Pero pag infinite na yung pinag-add mo, hindi na laging totoo ito. Alright? So meron kang kailangang property na kailangang masatisfy, and I think that property is called absolute convergence. At usually para ma-prove ang absolute convergence, gumagamit tayo ng konsepto ng uniform continuity. Alright? So medyo stretched itong application na naisip ko. Kasi naisip ko kanina, nangyayari to kapag uniformly continuous ang isang function. But I just realized na sa ano pala yan, dapat absolutely uniform yung hindi absolutely uniform. Dapat absolutely convergent yung series. Pero dun sa pagpapakita ng absolute convergence ng series, usually gumagamit tayo ng konsepto ng uniform continuity. Okay? Meron pa siyang ilang applications pero marami kasing preamble na dapat mabanggit. So kaya pala sa kabilang section hindi ko naisip na banggitin yan. Alright. So yeah, marami pang daraanan. Pero just to put a pin on that, tandaan lang natin itong mga necessary and sufficient conditions para sa uniform continuity. Because uniform continuity will go a long way insofar as further concepts, not only in analysis, but also in topology and application areas like convex optimization theory are concerned. Okay? So isang quick example before tayo pumunta sa huling segment na ng unit. So tingnan ulit natin yung function ng x squared. Yung reasoning ko kanina na ito ay hindi uniformly continuous ay nakapeg dun sa idea na kahit anong preliminary analysis yung gawin mo, yung delta lagi na makukuha mo ay laging nakadepende kay x sub 0 kung saan mo siya kinukunan ng limit o tinetest for continuity. Alright? Though medyo mahirap ipakita siya ng ganon kasi dapat ipakita mo na hindi porket nakakita ka ng isang choice for delta na nakadepende kay x sub 0, hindi mo pwede makonclude kagad na hindi na siya uniformly continuous. Baka hindi mo lang nahanap yung isang delta, kaisa-isang choice for delta o formula for delta na hindi nakadepende kay x sub 0. Kaya may butas yung reasoning ko kanina. Kaya naka-fingers crossed ako na sana walang magtanong kung bakit, sir, sufficient ba yan? Isang choice lang yan for delta. Marami pang options for delta. Baka hindi mo lang nahanap yung delta na hindi kasali si x sub 0 dun sa formulation. And you will be right there, right? So we need to be careful to show that any type of preliminary analysis cannot give us a delta that doesn't involve x sub 0. All right? Pero dahil meron na ako ngayon theorem corollary 3.5, kaya ko nang i-prove without batting an eyebrow na ito talaga ay hindi uniformly continuous. Ipili lang ako ng dalawang sequence. For instance, I can pick n plus 1 over n at saka si n. Dalawang sequences ng mga positive real numbers. Alright? Tapos, kunin ko yung difference, xn minus yn. Ang xn minus yn ay equal kay 1 over n, which converges to 0. Okay, so first two criteria are done. Now, let's see f of xn minus f of yn. F of xn is what? It's going to be n squared plus 2 plus 1 over n squared minus n squared. Yan yung f of xn minus f of yn. Tapos, maka-cancel yung n squared. Ito na lang yung itsura ng f of xn minus f of yn. Okay. It's 2 plus 1 over n squared, but when n goes to infinity, this guy will go to 2, not equal to 0. So, ibig sabihin, yeah, this will suffice as a proof na hindi uniformly continuous si x squared sa set of all positive real numbers. Kasi meron tayong dalawang sequence na ang difference nagko-converge kay 0, pero yung sequence of function values ay nagko-converge kay 2. So, hindi siya uniformly continuous. Pero if you really want, kung gustong-gusto mo talaga, gusto mong ipilit yung opinion mo na si x squared ay uniformly continuous, kailangan mag-adjust ka. Kailangan paliitin mo yung domain. Kasi ang problema kay open interval 0 to infinity, hindi siya compact. Hindi siya closed and bounded. Kasi ang sabi ng theorem natin kanina, kapag ka continuous siya sa isang compact set din, automatic siya uniformly continuous. So I will just restrict the domain of x squared to a compact set para kahit anong mangyari, sure ako si x squared dahil continuous siya doon sa kahit anong compact set, siya ay magiging uniformly continuous. And true enough, if I choose, say, the closed interval negative 10 to 10, it is closed, it is bounded, and hence it is compact, then si f ay uniformly continuous sa interval na ito. Si x squared ay uniformly continuous dito. Okay? Now, if you want to check using the definition, okay, pag kumuha ka ng kahit anong x at saka y na nandyan sa negative 10 to 10, sure ka ng distance between them. So this is the second correction for today. This should be x minus y. So yung distance mula kay x papunta kay y ay less than 20 units, which is the length of the entire interval. Okay? Pag pumili ka ng kahit anong x na nandun sa pagitan ni x and y, all right? Ang pwede mong gamitin na delta ay si epsilon over 20. Okay? And epsilon and that delta does not include the choice of x sub 0. Kasi ito ay mag-work sa kahit na nung x sub 0 na nandun sa loob ni negative 10 to 10. So we have a uniform choice for delta, namely epsilon over 20 for the entire closed interval negative 10 to 10. So we're done. Okay, so this is indeed uniformly continuous. Okay? If you want to prepare for the problem set, you can try to answer some of these exercises, okay? But do you guys have any questions before we jump to the last two theorems para sa Unit 3? Sige, break muna tayo ng 3 minutes habang nag-iisip kayo ng tanong. At medyo lumamig na rin yung kape ko. Kailangan ko nang ubusin. All right, thank you, Charles, for letting me know. Anong mga pinagkakaabalahan nyo lately? Huwag nyo sabihing ACADS pa rin. Though, I think that's probably your answer, no? Pero hopefully, naka-recover na kayo mula dun sa 2-week break natin, no? Kasi parang ako ay hindi pa rin bumabalik sa ACAD shape. Simula nung nag-long break tayo ng 2 linggo. Pero walang choice kundi magpatuloy, ano? Pero sana talaga matapos na yung summer o yung dry season natin. Kasi nabago talaga yung body clock ko. Kasi yung ginagawa ko ay natutulog na ako. Tulog ako ng umaga. Para kahit mainit, tulog naman ako, hindi ko siya masyadong nafe-feel, ano. Tapos nag-work ako ng usually starting mga 12 midnight papuntang hindi pala 12 midnight, mga 10 p.m. papunta ng mga 4 a.m. para malamig, presko habang nagtatrabaho. Pero hirap pa ako pag TTH kasi pag TTH dapat gising ako ng 11:30 to 1 At saka 2:30 to 4 para sa ating mga lectures. Medyo minsan naisip ko nga, bakit hindi na lang palang gawin ko ay i-play ko na lang yung recording nung last semester. So share screen ako with audio, ano. Tapos i-play ko lang yung lecture ko from last year. Tapos nakabantay na lang ako kung may questions kayo or hindi. Pero dahil hindi naman kayo nagtatanong or nagre-react, pwede akong natutulog habang nag-play yung YouTube video. Pero sayang naman. Na-enjoy ko rin namang dumaldal ng dumaldal. Ano? Okay, recess is over. Let's go to the last section for the course, and it's about the Intermediate Value Theorem. Now, syempre kilalang kilala nyo na dapat ito si IVT kasi mula Math 36 pa lang kilala nyo na to. Alright? And there will be no big change. Actually, walang change yung Intermediate Value Theorem natin dito sa Math 155. But basically, it's a nice result. Siguro nga lang nung 36 inisip nyo, pahirap lang yan, sir. Kasi lagi na lang ang tanong sa exam, find the number C that satisfies the conclusion of the Intermediate Value Theorem without any allusion to any of its practical applications, right? You have to wait until Math 175 to realize na, oo nga no, marami palang gamit yung Intermediate Value Theorems, especially in root finding techniques, right guys? So dapat yung mga 175 peeps dyan, makaka-relate. Ano? So, dahil ito ay unang-unang topic pa lang namin sa 175, yung bisection method, which is basically reliant on the Intermediate Value Theorem. And essentially, the Intermediate Value Theorem is so simple. Sinasabi niya lang kapag meron kang continuous function, lahat ng numbers sa pagitan ng function value ng left endpoint at ng right endpoint ay nadadaanan ng graph. Kasi nga, continuous yung graph. Drawing siya without lifting our pen. So, ibig sabihin, kung ito si f of A, kung ito si f of B, lahat ng number sa pagitan nila ay madadaanan ng graph kasi bawal akong tumalon. So, I am forced, since f is continuous, I need to draw its graph without lifting my pen continuously. So, lahat talaga ng numbers sa pagitan ni f of A at ni f of B ay madadaanan ng graph. Okay, yung mga numbers doon sa y-axis. So that's what we will try to formalize here. Kaya lang medyo dadayain ko yung approach. Ang gagawin ko ay magpo-prove muna ako ng isang lemma bago pumunta dun sa proof ng Intermediate Value Theorem. And the gist of the proof of the IVT will simply be an appeal to theorem point 10, which is the location of root theorem. Na alam na to ng 175 students ko. Ano? So ano ba sinasabi ng location of root theorem? So pag meron kang isang function sa isang closed interval AB na continuous, tapos ang function value ni A at function value ni B ay magkaiba ng sign. Pag we-multiply natin sila, ang sagot ay negative. So we are sure that one of them is negative and the other one must be positive. Then theorem 3.10 tells us na there exists a root between A and B. So we can find an x of 0 in the open interval AB such that f of x of 0 is equal to 0. And actually, you can think of it as a baby version of the IVT. Pero sabi ni Meta, axiom of ignorance, wala ka pang alam na IVT at this particular point in time kasi hindi pa siya na-stay. Pero yung theorem 3.10, ang sinasabi niya, so si f of A daw at saka si f of B ay dapat magkaiba ng sign. So kunwari si f of A ay gawin nating negative, tapos si f of B ay positive. Halimbawa yan. Tapos continuous si f. Si f ay continuous sa isang closed interval. Ang closed interval ay walang isolated points. So ibig sabihin, mag-hold yung characterization natin from Math 36 na mga continuous functions na ang mga continuous functions ay may mga graphs na nado-draw without lifting our pen. So, ibig sabihin, okay, ang graph ni f ay pwedeng magmukhang ganito. Halimbawa, it could behave crazier than that. Pwedeng ganito. As long as continuous siya, pwedeng ganito siya. Okay? Or whatever behavior as long as it is continuous or it can be drawn without lifting our pen. Pero simplihan ko na lang yung drawing. Ano? So, yan yung function f. Ang sinasabi ng location of root theorem, there exists a number x of 0 on the closed interval such that or on the open interval such that f of x of 0 is equal to 0. Okay? So ito yung i-prove natin. Tapos later, yung proof na ito, yung idea ng location of proof theorem, yung gagamitin nating pang-prove ng IVT. Now, how will we write the proof? Well, we'll do it this way. Bisection method. Ano? So, magko-consider, okay, nasa interval AB tayo. Tapos ang gagawin ko ay, hahatiin ko yung closed interval AB sa dalawang parte. So, through the midpoint. So, tawagin ko itong si C. Tawagin mo siyang si C. Okay? So, si C yung midpoint. Tapos, dahil si F ay may isang root sa pagitan ni A and B, then sure ako at least one of the intervals AC and CB will contain a root of the function F. Dahil sa buong interval, sure ako may kahit isang root, then alam ko na isa dun sa dalawang sub-intervals ay magkakaroon ng root. And the one that contains the root, siya yung tatawagin kong I1. So in this particular case, this is my I1. Kasi nandyan yung root. Tapos, so ito yung tatawagin ko ng A1, ito na yung tatawagin kong B1. Okay? Tapos, ulitin ko yung proseso. Hahatiin ko ulit yung interval A1 to B1 into two parts through the midpoint. Say the midpoint is somewhere over here. Tawagin ko itong C1. Alright? Tapos, dahil may isang root sa pagitan ni A1 at ni B1, then sure ako, at least isa kay A1 to C1 or kay C1 to B1 ang magko-contain ng isang root. Tapos tawagin nating I2 yung nagko-contain ng root. So ito yung tatawagin kong I2. Alright? So siya yung magko-contain ng root dyan. And I will redo this process over and over again until I come up with an infinite sequence of intervals I sub n. Now, what can we say about those intervals I sub n? Si I sub 1 ay superset ni I sub 2. Si I sub 2 ay superset ni I sub 3, and so on. So what we get is a set of nested intervals. Okay? Tapos, we are assuming here, without loss of generality, yun yung W log, without loss of generality that f of A is negative, while f of B is positive. Now, bakit without loss of generality? Kasi kung hindi to totoo, isa lang kasi yung matitirang possible case, yung f of B yung negative, tapos si f of A yung positive. Yung similar proof can be applied. Alright? Meron lang little adjustments. So, pagka ganun yung scenario na meron kang isang specific assumption na gustong gawin, pero the negation of that assumption will require a very similar proof, sinusulat na lang natin without loss of generality. Okay? Kasi hindi substantially magkaiba yung proofs para sa case na to at yung pakabilang case. So kaya W log na lang yung ginagawa natin. And then further, in this assumption, or under this premises, yung mga f of ANs lagi silang negative at yung f of BNs lagi silang negative. Alright? Kasi nga kung meron tayong isang target na root, okay? So laging yung mga left endpoints lagi silang negative. Tapos yung mga right endpoints lagi silang positive. Okay, ganun yung nangyayari. Kasi bakit nga 'to nangyayari? Kasi kung meron tayong isang target na root, halimbawa yung x of 0, yung target natin na root, okay? Lahat ng function value sa kaliwa niya ay laging negative. Lahat ng function value sa kanan niya ay laging positive. Eh yung mga a sub n's, dito lang naman sila nanggagaling sa kaliwa ni x sub 0. At lahat ng mga b sub n's, doon lang sila nanggagaling sa kanan ni x sub 0. Okay? So kaya pwede nating sabihin na, totoo, yung mga left endpoints, lagi yung function values nila ay negative. At yung mga right endpoints, ang function values pero may mga exemptions pala yung f of a n saka yung mga f of b n. Do I need to put that in writing? Actually, hindi. Pwede na lang natin siyang i-or just to be safe. Okay? So meron tayong nested interval. Now, hindi lamang nested interval, pero pag hinanap natin yung haba ng bawat interval na yan, ang formula ay b minus a over 2 to the n. So another correction, 2 to the n lang siya. Kasi yung yung I1, siya yung interval mula kay I1 mula kay I1 papunta kay B1. Yun yung kalahati ng interval AB. So ang kanyang length dapat ay b minus a over 2. Alright? Parang laging mali yung nasusulat kong ganito, no? Kahit yata sa 175, mali yung exponent ko. So, yeah. Ganun din dito. Dapat mabago siya. 2 to the power n. Alright. This formula holds kasi sa bawat paghahati mo, lagi lang nangangalahati yung length ng interval. And when n becomes very large, habang lumalayo tayo sa listahan ng mga nested intervals, and paliit point na sila ay mag-approach ng 0. Okay? So yung mga nested intervals natin, paliit sila ng paliit hanggang mag-approach ng 0 yung length nila. Okay? Now, dapat ito ay OR. So that means, dahil meron kang nested interval na yung lengths ay nagko-converge kay 0, ibig sabihin, sabi ng nested interval property, okay, yung mga intervals ay merong unique intersection. At yung unique intersection na yun ay yun yung limit ng mga left endpoints at ng mga right endpoints. So that's another correction. Okay? So yeah, yun yung intersection nila. Limit ng mga left endpoints, limit ng mga right endpoints. And what's the big deal about that? Remember that f is continuous. Since f is continuous, pwede kong kunin yung function value ng mga to. Okay? Tapos I'll use the property of continuity or characterization of continuity. Ang function value ng limits or ang function value ng limit ay equals sa limit ng function values. Alright? So the sequence of f of ans will converge to the function value of the limit of the ans. The same thing goes for this. Nagagawa ko to, napapagpalit ko yung order ng f at saka ng limit kasi si f ay continuous. Alright? So that means f of x sub 0 will indeed be the limit of an and bn. But what can we say more about this, guys? Well, remember that we know that an always dito sa sequence na to ay non-positive. Yung dapat ay non-negative, non-positive din. Okay? So bawat isa dito ay less than or equal to 0. So yung limit nila dapat less than or equal to 0 rin. Pero ang limit niya ay f of x sub 0. Alright? So ito ay by the order limit theorems. Okay? Tapos, mukhang naghang yata yung screen ko. Ayan, there you go. Naglo-load talaga siya. And then, ganun din, yung f of bn, lahat sila ay positive, lahat sila ay non-negative. Lahat ng mga f of bn's ay greater than or equal to 0. Sabi ng order limit theorems, kapag ka bawat term dun sa sequence ay greater than or equal to 0, yung limit niya, being f of x sub 0, must also be greater than or equal to 0. And here we have two things that must happen at the same time. Si f of x sub 0 dapat ay less than or equal to 0 and at the same time must be greater than or equal to 0. Isa lang yung pwede mangyari. F of x sub 0 must be equal to 0. And here we have shown na, si x sub 0 siya yung hinahanap natin na root ng continuous function f. And the bonus is that x sub 0 will belong to to AB. Because nandun siya sa intersection siya yung intersection actually. Siya yung intersection ng mga nested intervals na subset ng closed interval AB. So sure ako ngayon, this guy x sub 0 is in this interval. Okay? And that ends the proof ng location of root theorem. Okay? So what we did here is this guy. Okay? Meron kang function, halimbawa ito si f of a, ito si f of b, ito si ito si a, ito si b, function value niya, pwede siyang crazy dito, pero essentially continuous si function, so kailangan akong tumaas papunta kay f of b. So ito yung location of root theorem. Ito yung sinasabi natin na x sub 0. Okay? Now, yun yung idea ng location of root theorem. Now, let's look at the intermediate value theorem. Ano yung sinasabi niya? Just a quick recall. Kailangan ko siyang banggitin kasi meron tayong meta-axiom of ignorance. Ano? So, anong sabi ng intermediate value theorem? Kapag ka si f ay defined sa closed interval AB, tapos continuous siya doon, tapos si k ay kahit na anong number na nasa pagitan ni f of a at ni f of b, then we are sure that there exists an element of the domain whose function value is equal to k. Right? So nawala yung condition na dapat magkaiba yung sign ni f of a at saka ni f of b. So siguro lipat ko just to differentiate this with the location of root theorem. Diba? Ito si f of a. Kunwari. Tapos meron akong continuous function. So f of, ano ba, ito si f of a, ito si f of b. Okay. Tapos, sa kahit ano daw k dito, kahit anong k, sa pagitan ni f of a at saka ni f of b ay madadaanan ng graph. Alright? Kasi nga, continuous si f, so I don't have any choice but to go from f of a to f of b without missing any number in between. Kasi nga dapat continuous yung function f natin on the closed interval AB, which doesn't have any point, any isolated point. So dapat ito raw mag-join papunta ron. So ito yung y equals f of x. Okay, so yan yung sinasabi ng intermediate value theorem. If you get a k here, okay, we can always find a point on the graph, okay, na yung function value na yon, or that k is the function value at that point, and the pre-image belongs to the closed interval AB. Yan yung sinasabi niya. Laging may nag-exist na x sub 0. So paano natin to i-prove? Nag-exert na tayo ng napakalaking effort para i-prove yung location of root theorem. Umabot tayo sa pagbalik sa nested interval property, then probably we can make use of that, all right? Para ma-prove itong intermediate value theorem. And the proof can be done in a simple animation. All right? Paano ko gagamitin yung location of root theorem para ma-prove si IVT? It's quite simple. Gagawin ko lang ito. Okay? Gagawin ko lang, ita-translate ko lang to pababa. I will translate the entire graph of the function f k units para bumaba siya. So kung k units yan, na ibababa ko, yan yung mangyayari. Tapos ano yung nangyari rito? Si f of a at saka si f of b magkaiba na ng sign. Si f ay continuous pa rin. So by the location of root theorem, there exists a root x sub 0. And the function value of f at that root x sub 0 will be equal to k. Bakit? Kasi rito, ito na yung function na y equals f of x minus k. Kasi yung bagong graph, nakuha ko lang yan by shifting f of x k units down. Okay, so binaba ko siya. So, ibig sabihin, si f of a, obviously, ay naging negative. Si f of b naging positive, na-remain to be positive. So, ibig sabihin, magkaiba yung sign, merong x sub 0. So, there exists an x sub 0 such that its function value under the translated graph ay equal kay 0, right? F of x of 0 minus k is equal to 0, and then add k to both sides, you get f of x of 0 equals k as desired in the intermediate value theorem. Okay? So, pero meron correction dapat dito sa proof. Ano nga yung nakita kong correction dito? Okay. This one. This should be fx minus k. Na-realize ko siya kanina nung dinodrawing ko. Bakit f of x minus x? Mag-fix point iteration ba ako dito? Pero hindi naman. So binaba ko lang talaga yung graph k units down. Okay? There. Binaba ko siya k units. Tapos, and I think that's it. If you want to have a formal proof, sana pwede yung proof by animation. Ano? Pero that will give you an inspiration on how to write the actual proof. And the actual proof is given here. Ang daming sinabi pero isang drawing lang pala yan. Okay na yan. And that's quite amazing, which reminds me of this website. I don't know kung na-visit nyo na, brilliant.com. .com nga ba? Basta yung Brilliant na website. They do have good math problems, alright? Yung mga tipong pang quiz bee. Or pwede rin pang leisure na pag-iisipan nyo lang. And some of the proofs ay solutions, pinapresent nila graphically. So isa siyang magandang pag-practice. And you will see that, say, the Pythagorean theorem, and some other, the parallelogram law, ang dali ng mga proofs nila by just looking at them visually. Okay? Pero unfortunately, kailangan natin ng formal or informal proof that is in the form of a paragraph. All right? So, but essentially, you can read the proof there, and that's it. Tapos na yung unit 3. Yan. Credit natin si UPLB. Okay, any questions, guys? Okay, mukhang matatapos tayo ngayon before dismissal time. Ano? Ang yabang ko, pero ilang pages lang naman yung diniscuss ko, kaya mabilis na tapos. So, any questions? So, tapos na yung unit 3. So, watch out for the problem set tomorrow. Deadline ay Friday next week. Okay? Ano pa ba? Sorry guys, hindi talaga ako makabalik sa ACAD form. Hindi ko pa na-checkan yung homework 4 and 5. I'll try to start grading it tonight. Sana sipagin ako. Ito nga lang nakalipas na 2 or 3 linggo, puro proposals yung sinusulat ko. Ang dami-daming proposals na kailangang isulat. Tapos nakakapagod siya, nakakaubos ng English at saka ng brain cells. Ano? So hindi ko makayang mag-check. So, tapos pagkatapos ko magsulat, wala na. Mag-Netflix na lang ako hanggang alas 4 or alas 5 ng umaga para ma-relax. Pero yon, I'll try to do it para naman pag nagagawa na kayo next week ng problem set nyo, unti-unti nyo nakikita yung comments ko dun sa last 2 homeworks. Ano. Okay, so I think that's all from me for today. Do you have other concerns, queries, clarifications, violent reactions, or whatnot? So kung wala na guys, ingat tayo, and then good luck sa ating lahat this coming Monday. In whatever happens, we will get the government we deserve. So sana makukuha talaga natin kung ano yung deserve natin. Ano? So too many things are hinged on what will happen on Monday. So but until then, ingat muna tayo, and then kita-kita na lang tayo sa Tuesday na hopefully medyo light-spirited na at medyo masaya. All right? So bye guys.